Welcome again to this channel, Trusted Chemistry Solutions. In today's episode, we'll be discussing on the nature of matter. Like I said earlier in my previous episodes and introduction, that science is all about talking about matter. Chemistry is talking about matter. We want to understand matter because matter is everything that has to do in our environment, both internally and externally. Everything about this world is a matter. So we want to get to understand matter and try to see how we can use this matter to make our life easier, to make this world beautiful. So today, permit me to just go a bit to discuss the definition of matter, but we have discussed that in our previous episode, in our introduction. Now, what is a matter? Matter is defined as anything that has mass and occupy space. So definitely, we've seen that everything in our environment has mass and also occupies space. So, but today we want to look at matter in a different dimension. It is also going to help us in explaining a question that somebody asked in the comment section, where he's asking, what is material science? So with this, we're going to understand a particular aspect of matter that has to do with the study in material science. But we say that material science is an aspect of science that deals with the study of solid matter. So today we're going to look at the states of matter. We know that matter can exist as solid. Matter can exist as a living thing. Matter can exist as a non-living thing, and matter can also exist in what? As a solid, or as a liquid, or as a gas. So let us look at matter today in different forms. It can appear. There are three main forms, three main states of matter. But how is matter formed? Before we talk about matter, how it's formed, how the state of matter, we're also going to look at how a matter can be formed. What makes up a matter? Earlier, we've seen it in our previous episode that matter can be organic, matter can be inorganic. Right? But today, whether it is organic or inorganic, we want to see the state of matter, how it is being formed, what makes it, what are the building block of matter. Earlier in our introduction also, I talked about an atom being the what? As the smallest particle of a matter. Not in a living thing. In a living thing, the smallest particle of a living thing is a cell. But that's not why we are here today. We're here today because we want to understand matter in different perspectives. Now, what are the things that build up matter? Matter is made up of either the following things: of one, atoms. Secondly, it could be what? Molecules. And thirdly, it could be out of the formation of what? Ions. That is to say that if this is a matter, for example, that this matter can be formed either as a combination of what? Atoms coming together to form what? This atom, this matter. Or this matter can be formed either by the what? The combination of what? Molecules. It can be the same molecules, it can be different molecules. It can be the same atoms, or it can be different what? Atoms. Or it can be what? As a combination of what? Ions. When we talk about ions, we talk about what? elements that are what? That are charged. Molecules that are charged. Atoms that are what? Are charged. When we say that they are charged, means that what? They are either positively charged or negatively what? Charged. But this atom, this matter is formed by the combination of different what? Charges. So let me take this one first for atom. It could be one atom plus another what? Atom. To form a what? To form a particular what? Matter. Or it could be a molecule plus another what? Molecule. To form a particular what? Matter. Or it could be what? An ion plus another what? Ion. To form a particular what? Matter. So, these are the things that makes up a what? Matter. These are not the states of matter. They are saying that what? They are what makes up a what? Matter. Then let us go now. If we have understand what makes up a matter, then let us go into what? The states of what? Matter. How can we see this matter physically? How do they occur? How do they appear? Matter can exist in three main what? Forms. There are three main states of matter. They are: one, the solid state, or you can call it what? Forms. Number two is the liquid state. Number three is the gaseous state, which is the gas state. There are other states of what? Matter. Just talk like the There are other states of what? Matter. But they are grouped into three main forms of matter. The solid state, the liquid state, and the what? The gaseous what? State. I will explain them one after the other. Now, we must understand that the main reason why these three states are what? Are there is because of the fact that each of them is being described by their what? Their degree of movement, their freedom of movement, their intermolecular what? Forces, their interatomic what? Forces acting on them or present in this what? Matter. I will take the first one, which is the what? The solid what? State. The solid state of matter describe a particular group of matter which have a what? A limited degree of freedom, of limited degree of what? Movement. They hardly move on their own. Even when they try to move, they cause what you call what? Vibration. Right? That is because of the fact that what? Their atoms or their molecules or their ions are closely packed what? Together. That is to say, the force between one atom and another atom, the force between them is very, very what? Strong. Thereby, the force does not allow each atom to what? To freely what? Move. They are closely packed what? Together. Just like when you have in a building, you have a lot of persons in that place. You find that what? The degree of movement between one person and another person is what? Is very, very what? Limited. One person is conscious of the other person's what? Distance for him to what? To move. At times, for you to move, another person will be telling you, please, you are disturbing me. You cannot move. Can't you see that this place is what? There is no space in this environment. You see that there is difficulty in what? In movement. Only the only time that this body can what? Can move is only when there is a force applied. That's when you can now see that what? A solid material can then do what? Move. Also, a solid matter is one in which it has a definite shape. This shape can only be altered when a force is applied or when it's being what? Reduced, cut, or broken. Look at this. This is an example. Is this matter solid, liquid, or gas? Can this matter move on its own? It cannot move on its own. That's because what? Their atoms are what? Closely what? Packed what? Together. Now, can this matter change shape? No. It can only change shape when it's what? When you either what? Break it, or you cut it, or there's a force applied on it. Then this matter can what? Change its shape. Now, let's look at the second one, which is who? The liquid what? State. Who is a liquid what? Matter. How do you identify a liquid matter? In this area, the atoms are not closely packed what? Together. They can easily what? Move. That is to say, the intermolecular forces between one atom and another atom, or one molecule and another molecule, or one ion or another ion that makes up this liquid matter, that they are what? Far apart. There's a distance between them much wider than that of what? Solid. That is to say, their intermolecular forces or their interatomic forces or their interionic forces is very, very what? Low. But there is a force between them. That's why it doesn't take too much time or too much force to break or to what? To cut any liquid. Because ordinarily, the intermolecular forces is what? Is very, very what? Low. Also, another way to identify a liquid is that what? When they don't have a particular what? Shape. Rather, they take the shape of the container they find them what? Themselves. The third one, which is the what? The gaseous what? State of matter. This group of person or this group of matter, their intermolecular forces is almost what? Zero. They have very, very little what? Intermolecular forces. Or sometimes a zero intermolecular what? Force. Or interatomic what? Force. Or interionic what? Force. Almost zero. That is why they are totally free to move from one place to what? Another. Another thing again is that what? They don't have a definite shape. What they do, they take the shape of the container they find themselves. They occupy the whole space of any container they find themselves. That's the difference. Liquid do not occupy the whole space. Only when you continue up what? Adding the word, the liquid. But as soon as a gas enters a particular container, what it does is to what? Occupy the whole space. That's why when you spray a perfume in a particular place, you get to see that what? The whole place is being what? Surrounded by the what? The aroma of this what? Perfume. Because the what? They always want to occupy the what? Whatever environment or whatever space or whatever container they find the what? Themselves. Why? The atoms are freely what? They have free what? Space or energy to what? Enough energy to what? To move about. That is the differences. So with this, you can now see that what? Each of these what? States of what? Matter can easily be identified in your what? In your environment. You can now group a particular matter as whether it is what? Solid, liquid, or what? Gas. Matter that's in gaseous state can be compressed to become what? A liquid. That's something like a liquefied gas. Okay? Also that of what? The liquid can also be changed to what? Solid or to gas. So, if you look at the gas very well, you find that what? Any gaseous matter can also expand. That this degree of freedom makes it very easy for them to what? To expand. They tend to what? Take the complete shape of a what? A container. Another thing you must also remember is that for solid materials or for solid matter, they can appear as a what? A crystalline what? Material. What's a crystalline material or crystalline matter? It's a matter that has a what? A regular method of arrangement of its what? Atoms or molecules or what? Ions. That's why somehow you get to see that what? They begin to have a different kind of shape. Talking about either face-centered crystalline or body-centered crystalline and so on and so forth. But liquid and gas do not have such ability. But remember, they can be changed from one what? State to what? Another. A solid can remain solid at a particular temperature and pressure. Once its temperature has been taken to what? To a certain level, whereby the atoms of this atom, of this solid, begins to gain what? Enough energy. What do? They break out, they overcome the what? The force that is binding one atom with another. They get so excited that they begin to what? To break out from the what? From the what? The matter. They begin to go on their own. Sometimes they begin to what? To melt. They begin to fall down. They begin to roll down to what? To the container. Why? They have what? Gotten enough what? Energy for what? To move. They have enough kinetic energy at that point in time. The same thing happens. It can also be what? It can be a liquid what? A liquid material or a liquid matter that can be changed to what? Either solid or what? Gas. When the temperature of this liquid increases, what happens? It begins to change to what? To gas. Or when the temperature is being what? Reduced. Talking about freezing, it will change to what? To solid. So all these states of matter remain the way they are when the temperature and pressure is kept what? Constant. It's unchanged. Or when an external force is not what? Applied. Or when an external energy is not what? Applied. They remain the way they are. You can even know that sometimes solid can change also from solid to what? To gas. Without passing through the what? Liquid state. What do? They sublime. That is called what? Sublimation. That is the process called what? Sublimation. When a solid change from what? Its solid state to what? To a gaseous state. Without passing through the what? Without passing through the what? The liquid state. Ordinarily, solid is supposed to pass from what? Solid to what? Liquid, for liquid down to gas. But some solid do not do that. They jump the liquid state and go to what? The gaseous what? State. That's what we call sublimation. Sublimation. You say that what? The solid has what? Sublime. Example of such solid is iodine. As soon as iodine gets an increase in temperature, it changes directly to what? To gaseous what? State. Without passing through the liquid state. We're going to talk about all this method of what? Sublimation in our what? When we're discussing separation techniques. We talk about the sieving, talk about evaporation, talk about filtration, the distillation, decantation, fractional distillation, fractional crystallization, talk about chromatography, talking about the separating funnel, and so on and so forth. There's another type of what sieving, separation techniques that is not really discussed in most textbooks. When you have a particular mixture and you are trying to separate one from the other, and you tend to what? Blow breeze, apply air to it, and you need to see that there's a separation between one group and another word group. That's a different type of what? Separation word techniques. So we'll discuss about that in our next episode, or as we move on, as we progress in this channel. So please and please stay focused in this channel. Do not get carried away by any other thing, but please stay focused on this channel. Subscribe to this channel, like this channel, comment, and also share, such that when you subscribe to it, you get a notification as soon as the next episode is uploaded. I know also that at this point in time, you are beginning to enjoy science and enjoy what? Chemistry. At this moment also, you cannot differentiate between a particular matter, whether it is organic, inorganic, or whether it is what? Solid, liquid, and what? Gas. You also understand the fact that what? They are being grouped in this manner because of their what? The degree of what? Movement. Also, that if they can what? Occupy a particular shape, or if they have a particular shape, sorry, or they only do so as a result of what the container they are into. So please stay focused until we meet again. Bye.